All right, this is going to be dividing rational expressions. So we have 18x to the fourth over 5y cubed divided by 3x to the fifth, 25y cubed. So one thing, when there's two variables, you do not have to do excluded values because sometimes they will result in lines. This one doesn't. This one's actually pretty easy if you wanted to do excluded values, but we're going to not do them. So when we were dividing fractions in elementary school, or middle school, I guess, we don't actually divide them. What we do is we flip the sign to multiplication and we multiply by the reciprocal. So we are going to switch our second fraction, the top and the bottom. The first fraction is going to stay exactly the same. And then we can reduce either vertically or diagonally, not horizontally. Okay, so you have to either go diagonal, something on the top with something on the bottom, whether it's right underneath or crossed. Okay, just like our simplifying. So in this one, we have x to the fourth up top, x to the fifth down below. So the x to the fourth is going to go all the way away. We're going to go 5 minus whatever this number was, in this case 4, and we're going to be left with 1. If you wanted to do it kind of all long, x to the fourth would be 4x's, x to the fifth would be 5x's. So you would cross out one at a time, and you would be left with 1 on the bottom. Okay, so this is going to be x to the first. The 18 and the 3 can reduce. What's 18 divided by 3? It's 6. So the 3 is going to go to a 1. 18 is going to go to a 6. So far we have 6 and an x left. Okay, on the y's and the 5 and the 25, again, this is to the first power. So we're going to cross it off. We're going to do 3 minus 1, which gets us 2. So we're going to be left with y squared. And then 5 and 25 reduce. 5 goes into 5 once, 5 goes into 25 twice. 5 times. Okay, so we're left with a 5. Multiply everything together, so 6 times 5 is 30. And then it doesn't really matter the order you write the bottom in. Xy squared, y squared x, does not matter. And that is our final answer. Again, you do not have to do excluded values if it has two variables. All right, so that's monomials. That means there's no plus or minus sign. So it's kind of weird, but it's supposed to be the easier version. Okay. Over here we have a more normal problem. Okay, so the first thing I'm going to do again is just factor everything. So again, I can factor the ones that are a of 1 pretty easy. So -6 adding to -1, we'd have x minus 3 and x plus 2. 3x is going to stay the same. I'm going to keep my division sign because I'm just factoring right now. At the bottom's a little bit easier. We can factor out a 3x. We're going to be left with x plus 2. The top, I need to do a little bit of side work. So 2 times 15 is 30. Factors of 30 that add to -11, -5 and -6. So we'd have x minus 5, x minus 6. We divide by 2. This one's going to reduce to x minus 3. This one we multiply by our 2 to get 2x minus 5. 2x minus 5 and x minus 3. All right, so I can't cross out yet. However, I can list the denominators that I need to set equal to 0. I'm just going to put a little box over here. So we have 3x equals 0. We already have that once, so we don't have to do it twice. And then we have x plus 2 equals 0. Okay, so that's my start of my excluded value list. Okay, so I can't cross out anything until this sign is multiplication. So to make it multiplication, I need to switch the top and the bottom of my second fraction, or whatever's after the division sign. So we're going to have 3x, x plus 2 on the top. We're going to have 2x minus 5 and x minus 3 on the bottom. We're going to have the same fraction to start with. Okay, so nothing switches on that one. Okay, and then you can see I have some new stuff in the bottom of my fraction. So I need to set 2x minus 5 equal to 0, and I need to set x minus 3 equals 0. Okay, so that's my list. Now I'm going to look for what matches on the top and the bottom. So you can see we have a 3x and a 3x. we have an x minus 3 and an x minus 3. And then if you look on the top, we have x plus 2 and x plus 2. Since they're horizontal, they're both on top of the fraction bar, so they do not reduce. So we can write them as x plus 2 squared. And then on the bottom, we're just left with 2x minus 5. Okay, our excluded values, x cannot equal 0, x cannot equal, I was not on the screen, x cannot equal negative 2, x cannot equal 5 halves, and x cannot equal 3. Okay, so I just need to copy those down, 0, negative 2, 5 halves, and 3. And that is our final answer. So it's okay if it doesn't reduce down to like one nice thing. Sometimes it will, sometimes it won't. Okay, then we have one more. Let me erase the board real quick. All right, in our last one, we have, so this is number 9 on your notes. It's x squared minus 9x plus 20 over x squared plus 10x plus 21 divided by x squared minus x minus 12 over 6x plus 42. All right, so again, the first thing I'm going to do is just factor everything. So again, when a is 1, I can do it pretty easily. So factors of 20 that add to negative 9 are negative 4 and negative 5. 21 adds to 10. We have x plus 3 and x plus 7. We're divided by factors of negative 12 that add to negative 1, x minus 4 and x plus 3. 6x and 42, we can factor out in a 6, and we're left with x plus 7. Okay, so again, I'm going to just start listing my denominators before I switch my fractions. That way I don't lose anything. So I have x plus 3. These are excluded values. We have x plus 7. We don't need to do the 6, and we already have another x plus 7, so we don't have to do that twice. All right, so now we're going to change it to multiplication. We're going to switch our second fraction and rewrite the first one. We're going to look at our denominators and see if anything needs to be added to our excluded values. So you can see we only have an x plus 3 and an x minus 7, or x plus 7, excuse me. So we have that one, we have that one. We need our x minus 4. And then again, we have an x plus 3. We already have an x plus 3 in our list, so we don't have to list that twice. All right, we're going to look for what's on the same on the top and the bottom. In this case, we have x minus 4 and x minus 4. And an x plus 7. X plus 7. So what are we left with on the top? 6 and an x minus 5. On the bottom, we have 2x plus 3, so we can do x plus 3 squared. Excluded values, we have x cannot equal negative 3, x cannot equal negative 7, and x cannot equal 4. So I'm going to put that down here. So we have negative 3, negative 7, and 4. Again, the excluded values, I really don't care how you list them. Least to greatest is great, but you can see that I didn't. I just do it in my order that I solve. All right, and that is dividing rational expression notes. Okay.